Okay, the sequence that given to our group is DDN DN. So this is the state diagram that we draw up. So the first one is the mole and the second one is the milli. Next, we construct the state diagram by using quarters. So to draw the state diagram, we use the state machine. So this is all the setup for inputs, outputs, states, transitions, and also actions. So after construct the state diagram, we convert it into the Verilog HDL file. So this is the HDL file. Next, we set it as the top entity and compile it. Okay, after compilations, go to project, add current file to project. So we will get this folder. Next, for the waveform. So this is the initial setup for our waveform. And this is our output waveform. So after verified the mole state diagram, we introduce input filter and also night rider to it. So this is the overall circuit. So to run it, we set it as top entity and compile it. So this is the initial setup for the waveform. Okay, so that we can see that this is the output waveform. So after the correct sequence, which is D, D, N, D, N is input, the night rider will run for a cycle and produce an output done, which is used to reset the state diagram. So this is the reset. So after verify the previous circuit, now we introduce the prescaler. So this is the overall circuit that we're going to use in our CPLD. So first set it as top entity and compile. So after compilation, this circuit is good to use in our CPLD. Now we proceed to the second task, which is we are going to use one-hot encoding to replace the state diagram. So before constructing the circuit, we need to derive the next state equations. So this is the next state equations that we derive from the state table. So now we proceed to the circuit constructions. So this is the overall circuit. For this part is for state 0. This one is for state 1, state 2, state 3, state 4, 5, and also 6. We also introduce a go state indicator so that our circuit can run normally. So after all the connection is correct, we set it as the top entity and compile it. So this is the initial setup for our waveform. And this is the output waveform. So after verified the one-hot encoding, we convert it into a symbol file and connect with the input filter and also night rider. So this is the overall circuit. We need to set it as top entity and compile it. So this is the initial setup for our waveform. So this is the output waveform. So after verified the previous circuit, now we introduce a prescaler to it, and this is the circuit that we're going to install in our CPLD. So we set it as top entity and compile it. So after compilations, the circuit is ready to be run into the CPLD. Now we're moving to the last task, which is using binary encoding to replace the state diagram. So in this particular task, we're going to use a milli state table to derive the next state equations. So this is the next state equations that we derive from the table. So after deriving the equations, now we can proceed to the circuit constructions. So this is the circuit that we construct under quarters. So for this part is for Q0, this part is for Q1, and this part is for Q2. We also introduce an extra logic circuit which is used to indicate the current state. So after all the connections is correct, we set it as the top entity and compile it. Okay, so this is the initial setup for the waveform, and this is the output. So after verify the binary encoding, we convert it into a symbol file and connect with the input filter and also night rider. So this is the overall circuit. Next, We set it as top entity and compile it. So this is the initial setup for the waveform, and this is the output waveform. Okay, for the last part, we introduce a prescaler to it, and this is the final circuit that we're going to use in our CPLD. To do so, convert it into top entity and compile. So after defining all the inputs and outputs to its particular pin, we go to the programmer, choose USB blaster, go to add file, output file, choose the POF file. Then check all the program configure and start. So now we can proceed to the demonstration part.